walking the streets of ITF 2024, I'm seeing more and more applications on photonic integrated circuits. I'm here at a booth called Air Quality Sensing with peaks and with Jakob Heyden. Jakob, thank you very much for having me.
Hi.
What did you bring to ITF 2024?
Yeah, we built this demonstrator that is supposed to show you how integrated photonics helps us to develop high quality, at the same time, high quality and affordable gas sensors, in particular here for emission measurements from the livestock farming. That's what this demonstrator tries to show you.
You're using photonic integrated circuits for measuring certain absorption band. Which wavelength are you targeting?
Yeah, we're now starting at the telecom, so near the telecom range, I should say. We are currently targeting 1650 nanometers for methane.
Why methane? Why are you looking at methane?
Methane is, in terms of greenhouse gases, the most relevant one from the most prominent emission from livestock farming. Cows emit a lot of methane, but also in other sectors, like in the oil and gas industry, methane emissions contribute significantly to the overall greenhouse gas emissions. So if we can cut those, that is a very significant impact that we can have.
We have here an example of your chip. This chip is, can you tell us about the material? Is it silicon photonics or indium phosphide?
Photonics, yes. It's imec silicon photonics platform that we're using here. And in this case, this chip, what it does for us is it splits the input between 8 outputs. Mm-hmm. It switches between them, and we use 4 of those outputs currently. Those are the lines that you see here. So it produces an output in 4 different directions, and we can utilize that in different ways. In this case, so a very, very real-world problem is that if you would mount such a laser on one side of a barn, you send the beam across a barn. Mm-hmm. Then these barns are quite long, up to 100 meters long. Correct. So there's a good chance that through the seasons, as the structures move with temperature, you might miss the retroreflector. So by having an array of beams in slightly different angles, you will have one beam that hits the target. Yes. And you can automatically stay online through the seasons. So you develop a discrete spectrometer on a chip, and this actually is looking to measure gas sensing. So this in principle is a high volume market. Integrated photonics have reached high volumes in data centers. This is a very different landscape. How are you going to address the scalability of this chip? Yeah, that's indeed a challenge in gas sensing because the volume of the individual applications themselves are probably not sufficient to get costs really down to the same level that you might be used to from telecom. But with what we try to do now is develop the technologies that will serve different applications. And this technology is in principle similar, equivalent to the silicon photonics platform that was already put in data centers. Yeah, that's what you had to customize the wavelength a little bit from 1550 to 1650. How did you do that? Yeah, luckily I have colleagues that have that expertise to do that. I'm more on the system level. One of the biggest challenges that we had for photonic integration was to prove reliability to the key end users. We managed to solve that for data centers operating now 24/7 in a very harsh environment. How are we going to do this for the end users of greenhouses? How are we going to show them that integrated photonics can operate in the greenhouse 24/7? Yeah, that's indeed where OnePlanet is not only imec, but it's also Wageningen University Research. Correct. It's also Wageningen University. And within this partnership, we have barns that are experimental barns. We have access to these barns and can test our sensors. So we have the direct contact to the stakeholders. Jakob, what's your preferred future here? If we had this interview in 4 years, what things would you like to tell me? Yeah, I would like to tell you that there's a few hundreds of these in barns across the Netherlands, maybe also in Flanders already, maybe even outside in the EU, and that the technology has moved more towards the mid-IR, to longer wavelengths, creating higher sensitivity, being able to target more molecules than we can within the telecom range. Going to 4 micrometers to measure methane is, of course, a lot more accurate. However, QCLs, which could be the light source for that, is still quite expensive. We need high-volume applications. Are you interacting with this community and seeing how this could be one of the enablers of this higher volume? We have ideas, but that's as much as I can say about it at this point in time.
Thank you so much for a great interview, and congratulations on everything that you're achieving. Photonic integrated circuits here, a collaboration between imec and PhotonDelta on measuring gas in greenhouses. Thank you, Jakob. That was really cool. Thanks a lot. I really enjoyed it.